Good morning, afternoon, good evening, and welcome everyone. Thank you for joining this Elsevier Life Science Solutions webinar. My name is Harpreet Shah, Solution Marketing Manager at Elsevier Life Science Solutions. I will be moderating today's webinar, where we will be exploring recent advances and prospects of automation in the field of evidence-based medicine. Before we start, I would like to share some housekeeping items. So in order to achieve the best quality of the webinar, I would recommend you to view it in the full screen mode. You can find the button on bottom right corner. This webinar is being recorded and you will receive the link to the recording via email after the live broadcast. Also, you're welcome to ask questions during the webinar by typing them in Ask a Question box, and we will take them at the end of the webinar. The PDF of the presentation will be available afterwards in the Attachments tab, and along with that, you will have some additional Elsevier resources there. Also, in case you would like us to follow up with you, if you're interested to learn more from us, then towards the end of the webinar, we will have a poll where you could answer yes if you're interested in the solution, and we would contact you back. So now, introducing our today's speaker, Dr. Farhad Shokrane. He holds a PhD in evidence synthesis from University of Nottingham, and currently he is working as a research fellow at the School of Medicine at University of Nottingham. Farhad is an expert in systematic review methodology and automation, and he manages the largest database of schizophrenia trials to update over 340 systematic reviews. For this, he uses literature databases like Embase and other databases to provide search and consultancy services to academicians, industry, clinicians, and policymakers around the world. So Farhad, please share with us what do you have in store for us today with respect to the use of automation in evidence synthesis?
Thank you, Harpreet. Hello, everyone. Today we are going to talk about automation of systematic reviews, the process of systematic reviewing, and how we could use the existing tools and computer programs to facilitate the literature review. Before we start, I wanted to give a bit of background about what systematic reviews are and what is the difference between systematic reviewing and the other types of reviews that usually we know as narrative literature review. So the main difference is that in systematic reviewing, we follow certain steps. We set a specific question and we write a proposal like any other research. And then we follow step by step on choosing the literature that we are going to review. We set a framework on what data we are going to extract to answer our question and how we are going to perform analysis on the data. Compared to narrative literature review, that is not really following any steps. You could start and end your narrative review in any way that you want. You could be very biased. You don't have to follow certain structure. You could talk a lot about one thing that you like and ignore anything that is against your opinion. In systematic review, you have to stick to a certain question, and regardless of the opinions, regardless of the results of the research that may be against your own opinion, you have to include them in the systematic review if they are meeting your criteria. So the process of systematic reviewing, which is used for many other types of reviews, starts with a question. So the first thing is to look around to see if there is any literature at all to answer that question. So you run a scoping search that doesn't have to be very systematic, but it just shows you if there is anything outside in the literature world that might be relevant to your question. You may find enough literature, and without reading them, you may go ahead for the next step. You may find lots of literature or a lot of literature. So you may think that your question is very broad and you may decide to make it more specific, so you may modify your question. Sometimes you find too much literature or no literature at all, so you say that, no, I'm not going to do this systematic review or this literature review. In both cases, you could proceed writing a protocol like any other research. You write a protocol, you have a question, you have objectives, and you say what types of literature you are going to include in this literature review. You can actually publish your protocol. Either you decide to do the systematic review or you find no literature at all for your systematic review, you may still decide to publish it and inform people that there wasn't any literature or there are literature and I'm going to do this systematic review. Some people don't register or don't publish their protocol. But after that, when you have a protocol, you could proceed with searching as you've detailed in your protocol. Because the search is sensitive to make sure that you are not missing relevant literature, you may end up with lots of search results. That's why you need to screen the search results in 2 steps. The first step is to look at title and abstracts of the search results to decide if they are relevant, possibly relevant, or irrelevant. Then for those that are possibly relevant or relevant, you find their full text and then you screen their full text. And then you proceed to data extraction based on the protocol that you had. When you have the data, you may end up with summarizing them in table or as text. If your data are quantitative data, you may end up doing meta-analysis to combine the data from several studies in one analysis. And if you are doing qualitative research and dealing with qualitative data, you may end up with meta-synthesis. Some of the reviews may have a combination of these 3. When you are done, then you write a report. Majority of the systematic reviews end here. But some of them, for example, Cochrane reviews, they know that after publishing your systematic review, there are going to be new studies that might be relevant to your question, but you've already published your research, you've already finished your systematic review. That's why Cochrane reviews, for example, they keep updating their systematic review every 2 years, for example, or depending on the availability of the literature and if the literature may or may not change the conclusion of the existing older review. This is the process of systematic reviewing. You may follow this process, but not call your review a systematic review. You may follow the systematic reviewing process, but you write a scoping review or rapid review. Or you may call it a systematic review or realist review. So I'm looking at systematic reviewing as a process here, not as a single type of review. If you are interested, in 2009, a couple of information scientists wrote a paper to see how many literature review types exist in medical literature. They ended up with 14 different types of review papers. 10 years later, a team of information scientists updated that, and they realized that there are 48 different literature review types. I've added the citation for these 2 papers if you were interested at the end of this slide. This shows that not only the different types of reviews are emerging, their number is increasing as well. So depending on the type of the review that you are doing, the process of systematic reviewing may vary. It might be slightly different from the diagram that I showed you. Regardless of the type of the review that you are doing, it will include a certain workload and it will cost you. It is not always money. The cost sometimes is human resources and sometimes is your time. So you need to be considerate when you are doing a review that how much it will cost in terms of money, time, and human resources. And you need to consider this triangle all the time. If you look at the top of the triangle, I've put the human resources running on gears to show that the human resources, they don't have to do everything manually. They could use machines. So it could be a combination of human being and computer programs. When you start developing your protocol, there are many people prefer to do it in a Word document, Google Docs, or just a simple word processor. But some people prefer to use the existing systematic review programs because they provide headings, they guide you, and if you miss something, or if you have errors, they might be helpful in telling you what to write and how to write. So these three programs, all three of them old enough, they are suitable for developing your protocol or proposal for your review. There are other programs, and I'm going to give you the list of all the existing programs so that you could choose yourself among them. But these three have been very old, historical, and they have been developed based on the user experience during at least 1 or 2 decades. The main difference among these three would be the types of the reviews that they are supporting. EPPI-Reviewer 4 mainly supports complex reviews or almost any type of review. They are flexible. You could use the system to fit your purpose. So if you are doing a scoping review, systematic review, or complex literature reviews, you could use the system. Review Manager is more strict to Cochrane-style reviews. If you are doing prognostic review or interventional review or diagnostic review or overview in Cochrane style and following Cochrane guidelines, this program is useful. And JBI-SUMARI is relevant to at least 10 or 11 types of reviews, including scoping reviews, systematic reviews, and overviews. It seems very new. The automation looks like very new for evidence synthesis. But if we become a bit more open-minded, we realize that automation for systematic reviews was around since the first bibliographic databases became on disks and then online. We had a certain level of automation. We never had to look for each journal one by one because it is time consuming. Instead, we were searching Embase and MEDLINE because they were covering 5,000, 10,000 journals. So there was a level of automation in there, and it is interesting to know that librarians and information specialists were leading the automation since then, because they were helping researchers on designing their searches. Either they were looking for a single paper or a collective effort to identify the evidence. The librarians and information specialists were there to help their users use these automation tools, which are bibliographic databases. Recently, there was more coming for indexing this literature in databases. For example, Emtree, the controlled vocabulary used by Embase, and MESH, the controlled vocabulary used by MEDLINE, are using semi-automated indexing so that the machine finds and make text analysis on the literature and suggest the new terminology to be added to Emtree and MESH. These terminology later are being reviewed by human staff to be verified and added to this controlled vocabulary. Recently, there have been efforts by Emtree to use machine learning to identify adverse drug reactions. It has not been implemented yet, but there are ongoing efforts to see if we could identify adverse drug reactions from full text of the papers. And the reason is that usually it is very hard to find them. It is very important in terms of safety and pharmacovigilance, but because they have not been reported clearly in title and abstract of the literature, it is not easy to identify. Another feature of automation that you might have seen in databases is query expansion or auto-term mapping. You could see similar feature in Embase.com, PubMed, or Ovid MEDLINE, or even Embase via Ovid. What happens is that when you enter a term in search box, without telling the database that where to look, the database will decide to look for the term in certain parts of the paper. For example, when you enter migraine in search box and press enter, the database may decide, the search engine may decide that I'm going to look for migraine in title, abstract, and index terms. So it happens automatically. If you enter two terms, for example, migraine, paracetamol, without putting anything in between like Boolean logic, the database may use AND between those two. So these are the things that are helping the user. So it is something happening behind the scene that you could see later that are helping the user to find the best results. Another feature that databases were using is auto-term suggestion. If you are using quick or simple search in databases, usually as you type, the databases start suggesting the relevant terms. There are good advantages in this. The first one is that it saves your time. You don't have to type all the term. As you type, they show up and you could click on them or use arrow keys to select them. The second benefit is that it avoids spelling errors. So this feature existed in many databases for a long time. Recently, you could see that the databases are using more and more step-by-step guide for the users so that they could see what they need, they could structure the information need, and they could access the literature after following certain steps as wizards. I'm going to show you an example from Embase.com. And then when you finished your search, when you are looking at the search literature and the search results, there is an option in Embase.com called Index Miner that helps you to look at the index terms among the search results and guides you towards selecting more index terms that are relevant. This is an example of pharmacovigilance wizard in Embase.com. These features are not available in Ovid version of Embase. So here you could see that there are 5 steps from drug name, alternative drug names, adverse drug reactions, specific situations, and human limit. And in the second step, in orange box, you could see that Embase is suggesting me that there is paracetamol that we are going to search, but would you like to add 227 variants with OR? So you don't have to type them one by one. You just click on that orange box and it types them in with OR. And then in right-hand side, you could see that it suggests you what fields you want to search. This is an example of semi-automation. It doesn't do it for you. It shows to you that I could help you to do it, and then you have a choice to make. When it comes to the search step, we could look at different aspects of searching. The first part of the search is how to collect the keywords that you are going to search. Text mining has been very helpful in this stage because now we have at least 30 different tools for text mining. I've added Yale MeSH Analyzer because there were at least 2 independent reviews of this tool. And I thought that it is helpful that you could look at those reviews before choosing the tool. But if you are interested in more tools, there are reports and presentations from Julie Glanville that you could easily access online and read about different tools that exist for text mining. The text mining is looking for keywords in the text. So what you do is to show the machine that these are the literature, and you ask the machine to give you the relevant terminology out of this text. So the machine analyzes this text and gives you the relevant terminology based on the frequency of appearing in the text, and you could choose which ones are relevant. What Yale MeSH Analyzer does, for example, when you give the analyzer 10 or 20 PubMed papers that are relevant, it lists all the MeSH terms from all of them, and then you could look at them and decide what MeSH terms are very relevant to your search, and then you could choose them and add them to your search. The second part that many people find annoying is that when you write a search strategy for one database, because the syntax among different databases and search engines and interfaces is different, you could not copy and paste the same search strategy in other interface. For example, the search strategy that you've developed for PubMed is not going to work in Ovid because their syntax is different. That's why some of the information scientists have created PolyGlot, which is a tool that when you give it a search strategy, it automatically translates it to the syntax of at least 6 or 7 other databases. It requires editing by human, but it does 70–80% of the job itself, so it saves you lots of time. Also, this tool has been integrated into 2D Search, which is another tool for validation, visualization, and sharing the search strategies. When the search is finished, you are left with thousands of search results, probably. To manage the search results, you need to use the existing tools. You cannot manage thousands of search results manually. You may also decide to share your search strategies, and you may decide to use one of the existing tools to share your search strategies. For your search results, there are reference management programs, sometimes called Citation Manager or Reference Manager, but there are many of them. If you want to choose among them, I could easily suggest you one, but I'm not going to, because it totally depends on your needs. There is an independent survey and a review by a few information specialists and librarians. I've cited it here, Morphy et al. 2018. I suggest you to definitely look at it. It compares these 4 tools, EndNote, F1000 Workplace, Mendeley, and Zotero, and then gives you good hints on when to use each one of these and what are the advantages and disadvantages of these tools. The citations that I've highlighted and I've written in red color are the independent reviews, and I'm going to tell you what I mean by independent reviews. After you finished your search and you have your search results, it's time for screening. These are some of the tools that exist for screening. And again, I've put in front of each one of them, I put independent reviews that exist for each one of the tools. If you look at Covidence, there has been reviews in 2016, 18, 19, 20, showing the advantages and disadvantages of this tool. The same for DistillerSR, Abstrackr, Rayyan, and RobotAnalyst. So each one of these tools have been independently reviewed by people, and they've listed what is good about this tool, what is bad about it, and when you could use it, and what you should consider when you are using them. There are much more to talk about each one of these. Probably each one of these steps will require a separate webinar. But I've listed only a few of these tools just for your information, and I'm going to give you the links and the sites that you could access more tools. For data extraction also, there are tools, and some of them have been independently reviewed. So I've listed here DistillerSR as one of the oldest tools, Data Abstraction Assistant, Covidence, RobotReviewer, Exact, PlotDigitizer or WebPlotDigitizer, which is specific for extraction of data from figures. And you will be surprised to know that many people are using still Google Forms, Qualtrics, or SurveyMonkey. And there is a very good independent review from Lopez 2020. And I definitely suggest you to look at it, because they find that actually using these tools could be better than using any other tools. I don't judge any of them. I leave it to you to look at them to decide which one of these tools are the best and use it. And for meta-analysis and meta-synthesis, again, we have EPPI-Reviewer and DistillerSR and Review Manager, 3 of the oldest ones. Leximancer, which has been useful. I think there was an independent review that shows that it is useful for meta-synthesis of qualitative studies or text analyzing. We also have Meta-Analyst, OpenMeta-Analyst, Forest Plot Generator, MAVIS, DTA-MA for diagnostic test accuracy, Stata, which is probably one of the oldest programs in the field, and R, which is free, and it has a specific package for meta-analysis, and the package that covers some of the functions of systematic reviewing to help you. And Meta-Insight, which is quite new, but it is free and developed from funding coming from NIHR. What will be useful, instead of having separate tools that are covering only one of the functions, such as search or screening or data extraction, would be to have an ecosystem of all these functions in one program. And we already have it. We at least have 3 programs that covers some of these functions all together. So if anyone is interested in just using one program rather than separate programs, they can try these ones. And at the time that I was talking to my users, many of them prefer to use many programs, because each one of the programs offers something very special that you couldn't find in ecosystems such as EPPI-Reviewer, DistillerSR, or Systematic Review Data Repository. But some people prefer to work with these 3 because they are offering other advantageous points that you couldn't find in the programs that are supporting only a single function. What is challenging for the automation tools is that the first thing is the acceptance. Many people are not using these tools. They are not accepting to use it, and we are going to discuss why these tools have been underused. Some of these tools have been developed in a certain environment like social science department or clinical science department, so they are supporting the systematic reviewing process in certain fields, and you couldn't generalize some of them functions to the other fields. Many people have no resources to develop or use these programs, and we need a collaboration among these tool developers to work with each other to develop ecosystems that are working for everyone. And there are new tools, new technologies, and new developments coming so rapidly that it is not easy to catch up. So many of the tool developers are facing these challenges. And then when it comes to the users and the people who are going to use these programs and benefit from it, they are looking for more transparency. They say that I have no idea what machine learning is. I have no idea what artificial intelligence is. What I want is transparency. And then we have technological challenges, like how these tools could talk to each other and how we could create tools that are supporting each other. And then if we could build or merge 2 tools or 3 tools together, who is going to hold the intellectual property? Who owns these products? And then there are other challenges, if we have 48 different types of reviews, could one system support all these types of reviews, or do we need separate systems for them? How to extract data from full text, and how we could share this extracted data without breaking copyright. And finally, how to validate the machine learning algorithms and tools. So this is for you, how to choose a tool, which one is good for your purpose and your team or your users are going to love it. I would suggest you to look at independent reviews before doing anything. If you look at the papers that are published, majority of them are published by the software developers team. So they develop a tool and then they write a paper about it. And they say that we have no conflict of interest. But if you are looking for independent reviews, it is better to look for library and information science journals like JMLA and Canadian Healthcare Libraries Journal. Because these journals, and also Medical Reference Services Quarterly Journal, these journals are writing product reviews, and these librarians and information specialists were writing product reviews and research reviews for decades. These are the gateholders of high quality information, so you could trust the reviews that are written by librarians and information specialists, as long as they are not developers of these tools, of course. And then look at the surveys that are comparing these tools. Look at the independent surveys, like the two of them that I have cited here in red. Look for the evidence and the research that is done independently, comparing one or two of these tools to see which one is better and when. Because if you look at them deeply, you will realize that all of them are useful for certain user. And then ask your users, the people who've used these tools, ask their opinion, and if you can, actually share it. Share this user experience online for the others. If they've used Distiller or Rayyan or RobotReviewer, ask them what was good about it and what was challenging, and what is your suggestion, and share it online. And then see what function you need to use and how much it will cost, because some of these tools require subscription and payment. And sometimes it is actually worth it to pay this money to get the advantage and this function. And then it will totally depend on the type of the review that you are doing and how complex it is. Some of the tools are very flexible. You could use them for any type of review, and some of them aren't. A review from Elamin 2009 showed that when people are choosing these data extraction tools, it depends on how much resources, which means time, money, and human resources they have, and how complex is their review. If their review is too complex, maybe they cannot use any of the existing data extraction tools. They may need to design their own data extraction form. And then independent reviews. What are they? If you look at the papers, at the end of them, they say conflict of interest of the authors, and they usually say no conflict of interest. Even for the papers that are reporting a tool, the automation tool, and the developers of this tool are the authors of the same paper, they say that we have no conflict of interest. And you should not believe that, and you shouldn't trust that. Because if you have a baby, you would never say that my baby is ugly. Why do you expect the software developers to say that our database, our system, our automation tool is bad? They are going to say that it is beautiful. So the independent reviews should not be written by software developers themselves. Also, it should not be written by the competitor software or algorithm developer. Because if I have a baby, I may not say my baby is good or beautiful, but I can say that your baby is bad. And people will look at it and say that, yeah, he may be right because that is not his baby. But you need to be very careful when you are reading the papers that are written on automation. And sometimes it is not actually the developers of these tools, but these tools are using certain algorithm, and the developer of that algorithm starts saying that this tool is good. So you need to be very critical when you are reading the reviews that are written about the tools. My experience shows that the reviews written by independent librarians and information specialists or researchers and users that are not receiving any money or any benefit from the software developers are reliable. It is not a rule, but it is just my personal experience. You could always read these reviews and be critical about them, and that's the best way to choose them. And finally, ethics. You should ask yourself, also this tool is great, who is benefiting if I use the program? Are the people who are benefiting from this program are going to build a better program based on the experience that I'm giving them, based on that machine is learning from me, and then they are going to sell this tool to the people who don't have enough money to support it? Or are they going to sell the data that I've extracted as a volunteer? So these are the questions that you need to ask. And then you may ask who funded the developers. Are the organizations that are supporting these developers or the governments who are supporting them, these are ethical people. If I'm using this tool, am I supporting a certain government? Some people do not care because they say that the software developers are independent people. They are just doing this for the sake of science. But some people are sensitive about using the tools that have been supported by certain government or developers because they think supporting this tool is supporting the policies of certain organization or certain government. You may also ask, when I'm done with this project, am I going to have access to it, or when my subscription ends, am I going to lose access? Is there a way I could export my data before my subscription ends? Can I share my data using this system? Should I report it in my paper that I have used this program? These are the questions that people ask. Is there options for subscription for low and middle income countries or settings? I ask this question all the time, because majority of our users and the people that we are working with are not based in high income countries, and they couldn't afford to pay even a few dollars per month to access these programs. So there should be available options for people who do not have funding, even they might be based in high income country, but they may not have funding. For example, the students. That's why offering a specific student subscription or free subscription for one project per student could be a good option, shows that this program is ethical program. And then, how about the projects on COVID-19? Are they supporting that I have free access to these tools because I'm working on something which is a global health crisis? And finally, to get the answer, you may need to contact their teams. How to report the automation in your paper? We recently did a scoping review, and we used at least 4 tools. We used EndNote for removing duplicates. We used Rayyan for screening the results. We used Excel for data extraction. And we used RobotReviewer to extract certain type of data, 4 categories of risk of bias, which is the quality of randomized controlled trials. I don't say these tools are perfect, but based on what we had, based on our resources, familiarity with the resources that we have in our hand, and suggestion from the users, from our team, and previous experience and independent reviews, we decided to use these tools. Of course, we didn't just report that we used the tools, we also cited the evidence that it is recommended based on an independent review. It is recommended, that's why we are using it. We did the same for quality assessment. We used RobotReviewer for assessing the risk of bias in 4 categories of Cochrane risk of bias tool for included RCTs. And then we say that it is reliable because there are at least 2 research showing it, Also, these researches might not be designed independently, but it was the best available evidence that we had, so we have cited it. Why do people not using these tools? Why do they decide to do the things manually rather than using them? And it is a question for developers as well. Fear of technology. We have three main categories of users: the ones who are avoiding technology, the ones who love technology and they are waiting for the next technology to come around and immediately use it, and there are people in between. So some people are actually scared of using the technology, or they are scared that they may lose something, or machine does something and they couldn't understand it, or they may lose the data. Another part is lack of the evidence or independent reviews or reproducibility studies of these tools. And that's why I'm suggesting our audience that if they can, when they are using these tools, they could write a review. It may not be published, it could be just a blog, but when people are Googling that tool, they could find your blog about that tool, and that is very useful. Another resistance comes from the fear of being replaced by robots. Some of these tools are using machine learning, so whatever you are doing, the machine is watching you and is learning from you. Since the automation tools have been around for over 2 decades and they have not replaced us up until now, we could say that it is not a realistic fear. And then machine learning is very useful for repetitive and boring tasks. That's why it is actually good to use these tools, because these are tools. And then in most of the cases, they do a one-man job, when in systematic review, you usually require 2 people. For screening, for data extraction, for double-checking, you mainly need 2 people. So in the best case scenario, probably the machine could replace only one of these people, not both of them. And you will always require human approval for the tasks that require cognitive tasks and higher level. For example, when you are deciding if this evidence could be used in my clinic in the middle of a desert and when I don't have access to certain tools. That is something that you need a human to make the judgment, and machine learning cannot do it for you. And then we have a limited number of tools, really. Majority of them are focused on systematic reviews of randomized controlled trials, and some of them are tailored for specific needs. That's not very helpful for people who are looking for complex reviews or certain types of reviews. And then the machine cannot provide advice. They could analyze the data, they could provide you with information, but the final advice should come from the human. So we shouldn't be scared of being replaced by robots. And it is very slow. The progress of automation of systematic reviews is very slow. Many projects and tools come around and they disappear. One of the main reasons that people cannot use many of these tools is that they are mainly task-oriented. They have been designed for screening or data extraction or analysis. There are only a few systems that are cover everything in one place, like as ecosystem. Some of the tools disappear, they die, and they get forgotten because there is no real support for these tools. So whenever you are seeing that there is a small annual charge or monthly charge from some of the tools, don't look at it as something bad, because this small financial payment could support these tools to survive for decades. And the experience shows that they have. But the main issue is trust. Many people don't trust that the machine or the tool is doing the good job. And actually, they are right. Majority of these tools are based on the probability. They don't give you 100% of relevant papers with 100% assurance. They may give you 75% of papers with 100% assurance, but not the other 25%. That's why you will need to double check anyway. They are not disclosing the algorithm behind, and that is sometimes making people suspicious or skepticist about what is going on behind the scene. Some of these tools are complex, so majority of the users cannot use them. I have heard from many of the users that I have in my community, either from industry or academia, when it comes to R and the programs and the tools that are used using R programming or R Studio, they don't feel comfortable to use it because they think that it requires high level of programming or understanding system. And then people usually need to know that what is happening, and they need to see it with their own eyes. They need to double check what is going on. They also like to try the tools, and if the tool is not providing any trial period, they may not feel comfortable trying it. And finally, the tools must show that they have advantage over the routine practice. For example, if you could show that a tool could find and remove the duplicates as good or as fast as human or better than human, then that could be an advantage. There are other user perspectives coming from one of the workshops about 5 years ago, and it said that if there are trainings available for these tools, if there is enough user support, and if there is advantage over current practice, it is very likely that people start using them. If you look at these tools like EPPI-Reviewer, Review Manager, and Archie, they have been around over 2 decades, and they didn't replace us. They empowered us. And I could promise you that in the next 2 decades, these tools are not going to replace us. We are going to use these tools, and we are going to make the evidence synthesis process better and better and easier and faster and high quality, but they are not going to replace us. What is going to happen is that they may replace or remove some of the tasks that are repetitive, but they are going to create new tasks and new roles. They may also change some of the tasks or roles. So it is very important to know that the automation is going to remove some of the tasks, create new tasks and roles, and change some of the existing tasks. So they are not going to remove all the tasks, but they are going to remove some of them, which means be comfortable in using them. Also, around 2 decades, the search engines and bibliographic databases were around. Google didn't replace librarians and information specialists. Google gives you thousands of results, but your librarian gives you one answer. That is correct. So it doesn't give you confusion. All this experience shows that the automation is not true, but semi-automation is. If you want to stay up to date with the tools that are coming around about the automation of systematic reviews, I totally recommend you to visit this website. Systematic Review Toolbox, which is maintained by Christopher Marshall, is listing all the tools for all steps of systematic reviews. If you know of any tool that is missing from this list, you could contact Chris, and he will add it to the list. If you're interested in text mining for evidence synthesis, I definitely suggest you to read Professor James Thomas's works. I had the honor because he was my external examiner for my thesis. I found one of, probably it is 10 years old review that he and his colleagues have written on text mining in 2011, very useful, and I suggest you to look at it. If you are developing computer programs for evidence synthesis, read Vienna Principles. It is coming from iCaser, which is a collaboration for automation of systematic reviews. I definitely suggest you to read the meeting reports of this group and collaboration as well, which is published in Systematic Reviews Journal, because it is the edge of the development. If you want to see what's happening in automation of evidence synthesis, ICASER publications are the best ones. And then currently, there are efforts for integrating the existing automation tools and creating a list of standards. What I want to say at the end is that the information specialists were involved since the beginning of this automation. Either it was bibliographic databases, or it was automation tools, or talking to the users to use these tools. Information specialists were there. And the best independent reviews that have been written for these tools, for the automation tools, are coming from librarians and information specialists. So love your librarian. And for the librarians and information specialists, what is coming, what is the future, and they need to be prepared. The organizations and users that they are working with, they are going to contact them and ask them which one of the tools I should subscribe. Be ready, because they are going to contact you. They are going to ask about how much it will cost, how many users are going to use it. So from now on, it is going to become part of your role. Your users are going to ask you about which one of these tools are good for me. Not only that you need to know these tools and use them and suggest them to your user base, but you need to ask their feedback, and you could collect their feedbacks and publish it in library journals as the user experience. You could also write your own independent reviews in your website or journals. You may be asked by your head of division to develop materials, guides, and frequently asked questions for these tools. You may be asked to develop a new service or role as automation librarian and automation information specialist. You need to help people who are using these tools to report it correctly when they are writing a paper or in their dissertation, and make these reports evidence-based by citing the relevant research. And if you have students, you could actually start independent research on these tools. These are the references that I've used. I also listed one specific slide for independent reviews of these tools. At least I think they are independent. So if you look at them, you could critically appraise them. You could decide if they are independent or not, and you could benefit from the information that have been provided in these independent reviews. And if you had any specific question, you could ask now, or you could contact me if you think that you are more comfortable with email. Thank you.
Thank you very much, Farhad. This was very interesting. I'm sure it will also benefit our listeners in their evidence synthesis practices. So we have a few questions. I will open the floor for questions in a while, just to inform again our listeners that today's webinar is being recorded, and the recording plus the slides will be available after the live broadcast in the attachment box, along with other Elsevier resources. So now coming to the poll question. So I will launch the poll. You can answer by saying yes or no if you would like to be contacted by our Embase solution experts. So only if you click yes, of course, then we will reach out to you. Otherwise, you can skip it. So since we have just a very few, like 5 minutes, so Farhad, I will start with the question. So there is one question around, you mentioned publishing a protocol for a systematic review a team decides not to pursue. Can you talk more about that?
About publishing a protocol when there is no literature.
Publishing a protocol for a system. It says publishing a protocol for a systematic review, a team decides not to pursue.
When not to proceed?
Yes.
Yeah, that is the team's decision to publish or not publish, or register or not register their protocol. But the benefit of doing that is that you could receive independent review comments on your protocol, there might be something seriously wrong. So if you decide not to publish it or not to register it, I definitely recommend you to send it to 2 independent people that you trust. They are expert and they are not your friends, to comment on that protocol, because receiving critical comments are useful. Another thing is that you don't have to publish it. You could actually put it in one of the ePrint servers, and then that could be available before you start your review. The good thing is that if you make any deviation from any change from your protocol, you could see that there was something wrong. You changed your methods based on that, but then you report that you did this change, and that shows your academic honesty. By registering and publishing, the publishers will trust your work more, because they know that when you decided to do the research, you openly presented it to the public. And if there was something different from what you were supposed to do, you are explaining it. That's why that makes your research more reliable.
Okay, thanks, Farhad. So another question we have is about re-ranking. So it says, how about re-ranking? What are advantages of finding included articles faster? How do you know when to stop?
So is it relevant to the ranking of search results, or could you be more specific about it? Because if it is to do with the machine learning, it is not something in my field really. So either you could be specific, or you could email me separately, and I'm happy with more details to answer your question.
All right. Then we have one more. COVID has shown need for rapid analysis from vast amount of text. Any suggestions around that?
Yes, there has been several teams working on text analytics algorithms, and they've shared it actually online, the collection of the research, and also the algorithms that are available. Which one to use, I couldn't recommend any of them, because the assessing them will require quite a research and time. But what I could suggest you is to, instead of relying on the publications, and just go ahead with both published and unpublished research. Either they are in medRxiv, bioRxiv, or ClincialTrials.gov, or they are indexed in MEDLINE and Embase. I would suggest you to go for designing a search strategy as usual, and finding this literature and using some of the automation tools to reduce your workload. But I don't have any very rapid suggestion on that. The only rapid thing could be to involve more human resources to make it faster.
Thank you. We just have time for one last question. So first, this person congratulates you and says thanks for the nice information, and asks, please provide information regarding the tools to draw structures of chemical compounds.
Oh yeah, that is not my field, but I guess you had another webinar related to this. Is this correct, Harpreet?
Yeah. So I can maybe answer that. Yeah, exactly. Yeah. All right, Farhad. So we do have more questions, and I will forward you all those to you, and you can we can answer those back directly to the users. So, and in the interest of time, we will have to finish now. But definitely we will get back and answer all the questions we received. So once again, I will thank Farhad for his insightful presentation. I'm sure it must be very beneficial for our users. And also I will thank to our listeners for their attention. So until next time, please take care and stay safe. Thank you.
Thank you, Harpreet, and thank you, Iveta. Have a good day, all the audience. Bye.
Bye.